behalf of the Technology Association of Oregon, we'd really like to thank you for joining today's webinar. I know some of you are coming from various time zones, so we appreciate you joining us today. Just a little brief, the Technology Association of Oregon is dedicated to bringing together some of the brightest minds in the technology industry. It's the largest professional technology association in the Pacific Northwest in the United States. It's comprised of over 350 companies in Oregon and Southwest Washington that are involved or affiliated with the software and technology industries. This particular webinar is our fourth quarter webinar. It was organized by the Quality Assurance Forum, one of a number of forums at the TAO for different technology-related disciplines, including development, enterprise architecture, healthcare, IT. So if you'd like to learn more about the TAO or any of our forums, please check our website. I think it's listed there. It's techoregon.org. Excuse me. We'd also like to thank our sponsors who made this possible: Jenkins Business Applications, Rally Software, and Salesforce.com. So with that, this webinar will last about 60 minutes. It'll include some question and answer time at the end of the presentation. If you have a question, please feel free to submit that in the chat box on the webinar, or on the right-hand side, that on most people's screens, I think it is. And at the end, we'll do the question and answer session with those questions, as many as we can get to. We'll also make these slides available via the TAO website, so look for those in the next couple of days. So let's go ahead and get started. I'd like to introduce Trent Peterson, co-founder of AppThwack. It's a company that specializes in fast automated mobile-to-device testing services for Android, iPhone, iPad, and mobile web apps. Trent has experience as a senior software developer, and previously worked for Intel, where he was the lead developer for the automation framework responsible for testing Wi-Fi, WiMAX, and Bluetooth components. So with that, I'll turn it over to you, Trent. Is Trent unmuted?
Trent, are you there? I think he might have disconnected. Trent? Okay, one second. All right, Trent, are you there?
Yeah.
All right,
yeah.
Fantastic.
Can you hear me now?
I can.
Okay, great.
You're on.
Okay, great. So first of all, thanks a lot, Brian, for that nice introduction. And just to reiterate the thank you to Beth, Brian, the Technology Association of Oregon, and to all of you for joining in this discussion about automation. I think everybody that's attending is likely aware that this is a hot topic. It's becoming more and more important, so it's really nice to see so much interest in testing, quality assurance, especially around automation in the mobile space. So we'll skip over the introduction real quick since Brian did such a nice job. A quick overview of the agenda. So we're going to discuss sort of what we are trying to accomplish when we're talking about testing for mobile. What are the types of things that we would like to actually test? We're going to go over the problem space itself. So why is it important? What exactly is it? What are the numbers? And then why should we all care about quality? I think everybody in this webinar probably is very much aware of why it's important, but we'll hit on some points there. And then we'll dive into the when, where, and how. So how exactly we're going to automate, how best to approach it from a strategic standpoint, some best practices, some things that we can learn from previous software testing strategies, and then we'll do a whirlwind tour of some of the tools, mostly free, that exist today for helping us build quality apps, and then we'll open it up for Q&A at the end. So before we get started, we're going to set some ground rules. So what exactly are we talking about when we refer to testing? So you talk to people, and testing means a lot of things to a lot of different folks. Testing in and of itself is a profession with their own language and so on. So when people talk about testing, you hear lots of different words, lots of different types of tests brought up. So we have the functional, the non-functional, and so on. For the sake of today's conversation, we're going to distill these down into two key areas. We're going to talk about functional testing and non-functional testing. And for those that haven't heard these terms before, maybe they're a little, there's some questions about what exactly they mean. Functional testing refers to testing of the application for things that we actually designed for. So if the user clicks on this menu item, an image is displayed, right? So sort of an if A then B kind of situation. Non-functional testing is going to refer to things like power consumption while the application is running, network usage, those types of things. So sort of, we didn't maybe spec them out per se, but they definitely are important to building a quality application. So when we talk about the problem, basically writing software is a difficult endeavor, especially in today's atmosphere where you have literally thousands of different devices. And it's not just different devices, different screen resolutions that makes it complicated. It's also, we have to deal with people all over the world with different network conditions, different expectations, different CPUs, hardware specifications, and so on. So not only is software just intrinsically a difficult subject that requires some heavy engineering effort, we're deploying it into a very, very, very diverse ecosystem. So building things is hard. That's the problem area, and then why should we all care, right? I mean, building things, if software has always been difficult, then why do we care all of a sudden about it today, or why should we care about it specifically when we're talking about mobile? There are over 1 million apps in Google Play alone for Android. The same can be said of Apple's App Store, so we're talking over 2 million applications, right? Some of those higher quality than others for sure. But it's clear from these numbers that your application, when it goes to market, it's likely to have not just one competitor, but a handful of competitors, which goes to the next point that users are extremely fickle. The end customer is extremely fickle when it comes to this, and they have a lot of choice at their hands. So there have been studies done that show that you crash twice on a customer's device and they start looking for your competitors. And not only will they remove your application, right? I mean, that sucks. It's not good. But if they're really peeved about it, they start leaving things like bad reviews. And bad reviews, it's essentially they go on the public record permanently saying that your application is garbage. So it's not just one person uninstalling, it's potentially many people avoiding your application. So it's not the end of the world, though, because we have in fact seen situations like this before. If we roll back the clock 15, 20 years, we can look at how desktop development came along, and we had different sound cards that had to be developed for different video cards, different CRT monitor configurations, and different monitor configurations in general. So it was still a very diverse ecosystem that software was being deployed into, and they also had similar issues that we face with mobile today, where the tools are very immature, the industry is new, best practices are sort of coming along. Now, luckily, a lot of the tactics that they adopted, especially when it comes to testing and automation, can be applied to mobile without any modification. So essentially, we're not having to redefine an entire industry just to build quality applications. We can take a lot of the learnings there and then apply them to mobile. So when we start looking at automation and we set out to test in general, it's important to know what exactly we're going to test and what exactly we're going to automate. And to do that, we set goals. And if you talk to the empty suit, for instance, they might tell you that the goal of automation and the goal of testing, especially when it comes to automation, is to save time, to save money, and we're going to shrink QA. We're going to decrease headcount. We're going to save a bunch of money. We're going to make a high quality app, and they're going to tell you that we're going to automate everything. Now, this is the worst case scenario. That somebody that actually believes all of this. It's important to take a very healthy and realistic approach to automation. So let's set our expectations so that nobody is disappointed later, right? We are going to do automation so that we can increase the regularity of testing, so we can test more often and more consistently. It also is going to give us the time necessary to do things that people are really good at. So we pass off the mundane to the machines. They run their automation. We interpret the results. We maybe do some upkeep. But in general, our time is freed up to work on more important things. And the cool thing about automation and just computation in general is that it allows people to do things that they would never be able to do on their own. So suddenly we can do massively parallel tests very, very rapidly that would take people hours, hundreds of hours, and so on. So at the end of the day, those types of tests essentially do not happen, but with automation, they can. So when we talk about automation and we talk about being specific and being realistic, the first thing is, what are we going to actually automate? What are the first goals? So some questions that we can ask ourselves are things like, how often are we going to actually need to run this test? So is it once a day? Is it once a commit? Is it once a release? Do we do it quarterly for some sort of competitive analysis? It's really important to know exactly how often this type of test is going to be run. And secondly, is this something that a person is actually good at? So people are really good at evaluating look and feel, ease of use, those types of more subjective types of things, versus testing installation and making sure it installs across a few hundred different devices. That's something that somebody could do, but they're not particularly good at it. And then the final point is how much work are we actually going to have to do to get this thing automated? So if it's going to take us a lot of time to get it automated and we only run it once a quarter, then it's probably not the first thing we should automate. And this seems obvious, but time and time again, you'll see teams approach automation from an all or nothing standpoint. And like I said before, this is a very unhealthy approach to automation. It's very important to go in and choose things that really suck, that nobody wants to do, choose things that the machines are good for doing, and choose things that won't require a whole lot of work up front, because eventually we'll build our way into those types of tests, but there's no reason to start there. So some examples of things to automate. So things that machines are really good at, again, are things like unit testing. So these are things that we're going to run all of the time. They're going to test very specific pieces of the code base. Likely these are being written by developers. There's really no other way but to automate this, so it's an obvious choice for automation. But then we start talking about things that we do maybe over and over and over again, very mundane tasks like testing to make sure that our update works and that data is successfully transferred from the old version and interpreted by the new version of our application. And performance is another instance of things to automate, because a person is simply just not able to do it manually, or it would require somebody monitoring equipment, which is a waste of time. Things that people are really good at and things that should remain manual, at least at first, are things like user experience testing, responsiveness, and look and feel, as well as new functionality. So ideally, our automation is covering the nuts and bolts of our application, and it frees up our team to look at brand new functionality and do exploratory testing on it. And then as those types of tests mature, then they get automated, and so on. So when we talk about automation and we talk about testing, we have some options of where we're going to actually execute these tests. So let's say we start writing automated scripts and we start writing automated tests. Where are those tests actually going to go? On the Android side, we have the JVM, and the JVM essentially lets us run our Android code in a headless environment without the overhead of a lot of the system components, anything that would be emulated typically or on a real piece of hardware. It guts all of that, so it gives us a really, really easy way to test small pieces of functionality. By default, it's just going to test, it's going to be good for unit tests. And it uses mocks. So when I said that it lets us avoid some of the emulated pieces, so instead of talking, for instance, to a true GPS, we're going to talk to a mock of that GPS that gives us dummy data, essentially. So it's good in the sense we can run it all the time. It's maybe bad because it doesn't totally reflect an in-system. But tests on the JVM aren't really supposed to do that in the first place. So next up we have emulators, or simulators on the iOS side. So emulators are cheap. You can run them locally. You can run them in the cloud. They're great for catching layout issues, although nowadays we have some additional tools. specifically on the Android side, to let us do that very quickly. We can do interesting things like traffic shaping on the network and simulating SMS and phone calls. On the downside, on the Android side for emulators, they're notoriously slow. There's been some headway there, but they're still not anywhere near as fast as either the JVM or even on running on a real device. On the iOS side, you have simulators, which have their own set of issues. Instead of being slow, they just simply don't reflect the actual end user environment or the hardware environment. So they give this illusion of being a one-to-one mapping, so you can have false positives or spend time debugging an error that actually doesn't truly exist on the end device. And the final piece when we talk about machines is we can test on actual real hardware, and you'll see many people doing this. You likely have cabinets at your facilities full of devices, and you test on them periodically just to get a true feel of what the application feels like on those devices. So again, they're exactly what the end user uses, so they're perfect. They're one-to-one map. They're going to give you true real-life performance data. So when you're looking at CPU usage, you actually know it's the true CPU usage from the device and not an emulated one. They're very fast. And the downside, again, if you have them in cabinets, you likely already know this, they're very expensive. Somebody has to be in charge of purchasing them. And not only that, but then maintaining them over their lifetime. So keeping them charged, keeping them updated, and so on. So in addition to testing through automation on the various types of machines, we also have actual real people performing tests manually. So we have QA teams, and some of you on the call are likely on QA teams. So the cool thing about QA is that they're professional testers. They know what to look for. They're going to provide real feedback. They likely know the product, so that feedback is actually going to be very valuable and informed. The downside is that it's human capital. It's expensive to have them performing tests, to have a QA team performing tests. Another option for people is to utilize the crowd, so sending out an application to end users, or not end user, sorry, but sending it out to basically a virtualized QA team. Again, they're going to provide real feedback, just like real people. The downside is that they might know the product, but likely they do not. It depends on the type of service you're using. They're usually expensive. They're definitely more expensive than automation. And because they're people, it's going to be somewhat slow. So they're good for some tasks and definitely not good for other things, especially redundant, mundane tasks. And then the final one is end users, and this is not an option, even though you'll see it time and time again where people will sort of throw their hands up in the air, push an app to market, and then find out that the application doesn't work or a certain feature doesn't work on a subset of devices or in certain network conditions. So I would highly advise you don't do that, and I think more and more we see people shying away from this, especially given how competitive the market is. But definitely nobody wants to be your guinea pig. So now we'll go through sort of some high-level automation strategies. These are like, for the most part, these are adopted from just general software automation strategies that we can apply to mobile. They're just a healthy approach to automation. So first and foremost, we do not want walls between our dev and QA teams. Time and time again, it has been shown that when a development team and a QA team are sort of set at the opposite end of the spectrum, and they're essentially put a versus between them, so these two organizations are fighting each other. This is not healthy, and it's not conducive to effective testing. Ideally, the dev and QA team have a lot of respect. They work very closely. In some cases, they're actually indistinguishable. The dev and QA team are sort of an amorphous organization. This is ideal because it means that they're all adopting the same strategies, the same approaches to testing, the same respect for not only testing but also the automation and the tools being used, because there's a notorious problem where QA will adopt a set of testing practices, especially when it comes to tools and automation, pass those results off to developers, and the developers will say, well, I don't believe your automation, right? I don't trust that automation. You know, the first thing, you know, and I speak as a developer, is to blame the tool before I would acknowledge that, you know, maybe my code actually has a problem. But if everybody's on the same page, you get to avoid that. The other important part of having dev and QA be very close together is because automation is a software project. So when you think of an application, if we wanted to test it in an exhaustive manner, we're going to have an automation code base that is at least as complex as the software it's testing, at least. And it's likely even more complex because you'll start testing for some of that non-functional stuff that we talked about earlier. So automation is a very complex topic, but time and time again, it's treated as something that an intern could do over the weekend, or it's something that non-developer QA people are going to do, and then they're going to maintain this code base, and they're going to have a 100% test coverage. It's simply not realistic. So automation is 100% a software project, and it needs to be treated as such, and it needs to use the same processes you'd use for any software project. So this requires planning, it requires source control, it requires all of the best practices that go around software. Treat automation with the respect that it deserves. It's important that we keep a healthy mindset here, and that we don't treat automation as a solution. So we're not going to start automating tests and then suddenly our application gets a 5-star review. We had quality issues before, now we have automation, and now the quality issues go away. No, the automation is a tool that will help us get there, hopefully, but it's very important that we look at it as a tool and not as some sort of goal that's going to result in some outcome, right? It's just a component in that. It's all part of, as long as the organization has a healthy approach to testing and a healthy approach to QA, then automation is just another tool in their tool belt. It's important to be successful with automation that we don't just automate 100% of everything, and this is typically actually on the ground. When you have developers or QA folks doing automation, you rarely encounter somebody who's looking for 100% precision. This typically is a management decision. But it's very important that we look at what we're doing today to test, where we can free up the most time, what's the most painful stuff, and let's start there. Let's start with those things that don't take a whole lot of effort to automate, but free up the most time or relieve us of the most pain. One of the beautiful things about automation and just software in general is that it lets us do a lot of things very, very quickly. So when we start writing tests from an automated standpoint, we can start to data drive those tests. So we might have, typically in a QA run, we might have the testers do maybe 10 different ways of doing something. So we launch the application with Wi-Fi, we launch the application without Wi-Fi, we launch it with a 3G connection, and so on. All of those are things that we can data drive from an automated standpoint. And so the more parameters that we can pass into our test, the more code coverage we can achieve. Now, when we start talking about all of this data, and we start talking about data driving tests, we end up with a matrix. And depending on how complex your application is and how excited you are to actually data drive your tests, you're going to end up with a very, very large matrix. And when you start running the numbers on how many combinations you can come up with, you're going to come up with, it's easy to get into the hundreds, if not thousands, of iterations. So once we start doing things like that, automation's great until it's dumping so much data on you that you don't know how to interpret it. So it's really important that you know what the risks are, the riskiest things when you start data driving, so that you can still pick and choose. You don't, maybe, even though you could run 100,000 iterations of a test, maybe you only need to run 1,000 or 500 or 200, whatever it may be. But it's very important that you approach it with that mindset. And lastly, when we start talking about automation, one thing that comes up time and time again is that automated scripts and automated tests, again, they're software, so they're very difficult to maintain, or notoriously difficult to maintain, but they don't have to be. So if we come at it from the software project standpoint, then we know that we don't want to hard code sleeps into our code, for instance. We don't want to write the same boilerplate code over and over and over again. So what we start doing instead is we start building up libraries of abstraction, so that when we go to write tests and automate tests, we're using building blocks. We're not writing code at the most basic level. And I think that this is obvious if you approach this from a developer or a development standpoint, but maybe not so obvious if you approach it from the we're going to automate everything standpoint. Now, abstraction is important, but it's also important that you don't become obsessed with abstraction. So it's fairly common to have people say that they want to write tests that will be multi-platform, for instance. So we have an iOS version of our application, an Android version of our application, maybe a Windows Phone version of our application. And then we're going to write tests, but we're going to write our tests just once, and they're going to work across all those devices. It's a great goal, but it's important that you don't get sidetracked trying to sort of force, you know, a square through a round hole here. So use abstraction, but use it wisely. So now for the whirlwind tour of some tools and frameworks that are available to you to make your life a little bit easier. So a lot of these are frameworks for actually writing automation. Some of them are tools to make your life easier. So we're going to give a high-level overview of each of them, and at the end we'll do a Q&A session if you have any questions about specific tools. So one type of tool to talk about are recorders. So again, I keep on saying over and over again that automation is a software project. There is a thing called a recorder, and it's usually marketed as a way for non-developers to automate tests. And it does deliver automated tests, but it's important that we know the pros and the cons of this approach. So on the pros side, recorders let you get up and running very quickly. You can take just about anybody who can install software and have them record a flow through the application and generate a test. And when they play it back, it hopefully does exactly what they did. Now, on the downside of this is that because it's a recorder and it's not it's not generating the most beautiful code, it likely results in a very fragile script at the end of the day, and it's going to have things like hard-coded weights. It's going to maybe pick up on some things that aren't part of the test that you happen to do. So maybe you moved the mouse across the corner and it, you know, highlighted some menu item or something like that, right? So it's not like the test is going to be very clean at the end, which means it's also difficult to maintain unless you go in there and you start cleaning it up and essentially rewriting it from a software perspective. And the bad side again is that, you know, it's great because non-developers can create tests, but it's also bad because it sets maybe the wrong expectations that we're going to end up with a fully automated set of tests. Now again, it's really fast, so it's great for proof of concepts, but long-standing healthy code probably not. So I would recommend that you treat recorders as a fancy spy. So when I say a fancy spy, it essentially lets us peer into the application, especially if we don't necessarily have the code, if this is a black box testing environment. It lets us go through the flow of the application and then look through the script it generates and get a rough idea of what exactly we're dealing with. So then we can take that rough skeleton and start actually making it into a decent set of code. So some specific tools that are available to us. One, that if you're on the Android side of things and you've not heard of the Exerciser Monkey, you definitely should take advantage of it. It comes with the Android SDK, so you can just run this from the shell. And it basically hits your application with random input for some allotted amount of time or events. And it's great for finding performance issues, memory leaks. It often results in ANRs. So it's just a great tool. It takes very little to use it, and it's just going to hit your application with random input. So it's not a smart tester, but it's a nice little smoke test that you can do on your build. When we start getting into actual focused automation, not just randomized testing, we have quite a few frameworks available to us. So the first few here are going to be Android. We're going to talk about a couple cross-platform tools, and then we're going to talk about a few iOS tools or iOS frameworks. The Android testing framework that comes with the SDK, it allows you to write JUnit unit tests for your Android code. It has instrumentation that provides integration with the Android SDK, so it allows you to actually do some control over the application, as well as testing your software code directly. And then it also, because of it's just for unit tests, it has very basic functionality. So it's not going to do the functional kind of testing where we're actually interacting with it like a user, it's going to be a little more low level than that. But because it comes with the SDK, because it's great for unit testing, my assumption is that if you're on Android, your developers are likely writing these tests already, or if not, they likely will or should be. If you're writing tests in JUnit, then you can use Robolectric, and Robolectric is a really nice way to run the JUnit tests in a JVM. It has mocks for a lot of the pieces that the default SDK does not have, so you can actually do some interesting things here. It's not going to have every mock though, so for instance, if you're using something like location services, you might find partial support or a partial mock for bits and pieces, but it's not going to be a full one-to-one mapping to the end, your end functionality that you're looking for. But again, if you're doing unit tests, which you probably are or should be, there's really, Robolectric would be the go-to tool for actually running them. UI Automator is actually supplied by Google. Again, it sits on top of JUnit, and it extends that framework that we were talking about so you can actually interact with the UI. So it provides a bunch of helpers so that you can, for instance, find controls and touch them or swipe them and so on. So it lets you actually mimic a user for functional testing. And because of the way UI Automator specifically is designed, it allows us to write handlers for system dialogues. So by default, a lot of the frameworks are limited to controlling just your application under test and can't really get outside of it. So if a system dialog pops up, for instance, you're usually hosed. In the UI Automator world, it's not the case. You can actually write code that will handle it if a system dialog comes up, or if you need to go into a different application and do a couple, change some settings over there. It lets you do that, which none of the other frameworks we're going to talk about actually allow for. The downside here is that it's Jelly Bean and up. So unless you are only supporting Jelly Bean and up, which is highly unlikely, it's maybe not the best automation tool for the job today. However, we do see quite a few people, quite a few organizations writing newer tests in UI Automator, especially for UI control and that system level testing. But then for the backwards compatibility and regression testing, they're writing tests in one of the other frameworks that supports pre-4.1. Another framework also from Google is Espresso, and it's brand new, and I just will mention it very, very briefly. It also sits on top of JUnit. It also provides helpers for interacting with the UI. One cool thing that it does is it provides a method to bypass the typical waits and sleeps that you would find in your test code. So you essentially chain test steps together, and it takes care of waiting for elements to appear in the background. So your test code is very clean. It's brand new. It actually was released in mid-October. It remains to be seen how Espresso will play into the UI Automator world, since they're both Google technologies. Also, because it's new, it's fairly unstable. Documentation is fairly sparse as well, but that will change as the tool matures. If you're feeling adventurous and you like the idea of writing a very clean test code, I would certainly recommend at least giving it a try. And since it sits on JUnit, the investment from your side just to try it out is fairly low. Robotium is probably the most mature framework on the Android side. It also extends JUnit. It can run on both emulators and real devices, and that could be said of the previous frameworks as well. It's definitely oriented towards a black box testing environment, and it provides the tools you'll need to find controls based on text or based on ID, and so on, and then let you actually run those simulations of user behavior. Like I said before, it's unfortunate that it's limited to the app under test. This isn't a limitation necessarily of Robotium, but Android permissions in general, and they would have to come up with more of a client-server model to mimic a UI Automator scenario. And if you're looking to do functional testing and you have a development team or a skilled QA team that's skilled in software development, specifically Java, then Robotium is going to be an excellent choice, especially because it's so mature. Now, cross-platform test environments, we can look at Cucumber. Cucumber is largely focused on behavior-driven design, so it lets you write business logic, and specifically this kind of business logic is written in in a human-readable form. So your test will literally read like, my application launches, and then I take a screenshot, then I log in, then I take a screenshot, and so on. So you can quickly write tests that are written in pure English. It's also cross-platform, like I mentioned. The downside to this is because it's so high level and it's behavior driven, the steps that they call them, so those things like, then I take a screenshot, that set of steps it comes with are fairly limiting. So for high level flows, walking through your application, it's really easy to get up and running with a Cucumber-based framework. However, as soon as you want to do any more low-level stuff, or you want to do stuff in the background, you want to assert certain things on the device, for instance, you're going to have to write custom code. And the more and more of that you do, the more and more overhead you're going to have to endure. So no matter what, you're likely to end up having to have somebody who has software skills on this. So even though up front it looks like you could take, oh, anybody can write tests, at the end of the day, that's not really the case. You're going to need somebody who has some software development skills to truly make the organization successful with the Cucumber-based framework. Examples of Cucumber-based frameworks, one of the most popular ones is Calabash. Again, cross-platform, and lets you write Cucumber tests against iOS and Android applications. Another newcomer to the automation world, for native testing at least, would be Appium. And Appium is essentially Selenium for native applications. So if your organization has experience with Selenium, then Appium is definitely something that's going to be right up your alley. They have a bunch of language adapters, so you're not limited to just writing your tests in Java, for instance, or Ruby. You can pick and choose. Supports real devices. Again, it's cross-platform. One of the downsides to it, and this will change over time, is that because it implements WebDriver, not every single piece of WebDriver really maps one-to-one with native applications. So there's some weirdness there. If you were to come into this and not be super familiar with Selenium, you might not understand what certain things are referring to, or why certain things don't matter when it comes to your application. For instance, cookies is a good example that exists on WebDriver that maybe don't make a whole lot of sense in the native world, usually. And so if you're doing Selenium development already and you're looking to move into native application testing, then I'd say that Appium is definitely something to check out. On the iOS side, Xcode comes with UI automation. UI automation is great. It's very fast to get up and running. Again, it has a recorder, which is both good and bad. It lets you get up and running very quickly, which is a plus, but it also is a recorder, and so it has all of the same downsides of any recorder. It generates fairly fragile code that will need to be maintained by the team. The language it uses is JavaScript, which is nice because it's a fairly simple scripting language with tons and tons and tons of documentation. On the downside, maintaining an automation test base or code base written in JavaScript is going to require you to find some decent tools to do so, because you're going to actually be writing JavaScript, and there's a little bit of overhead there. It's probably not the easiest thing to maintain. You're going to have to go into a separate environment to be successful. But for getting basic tests up and running, it's an obvious choice on the iOS side, again, because it installs with Xcode and it's just there out of the box. XC Test is another Apple provided project that comes with Xcode. You write your test. This is similar to the Android testing framework concept. It's a unit testing framework. You write your test in Objective-C. The downside is that XC Test, it's somewhat replacing, they had a previous unit testing framework called OC Unit, and it's what they're pushing in place of OC Unit. Because it just came out, the documentation is extremely sparse. That will change over time. But again, it's something to consider, that it's going to be an adventure getting into it. But since it's what they're pushing, it's probably a safe bet that XC Test is going to stick around for a while. If you're writing unit tests, it's the obvious choice for iOS. For functional testing of iOS, KIF is a very popular choice, and its ancillary would be Robotium on the Android side. So it's a functional testing framework that requires some development chops. But assuming you have those, it's very powerful, and it lets us do a lot of really, really interesting functional tests with our application. So again, it's Objective-C, specifically for functional testing. The downside, or a risk, I should say, is that it uses undocumented APIs. A lot of the frameworks do this, but KIF is very, very invested in those undocumented APIs. It has a big user community or a big developer community, so chances are if those APIs, if Apple was to change those APIs, they would be fixed. But it's certainly a risk because Apple can pull those or change those at will. But again, if you're writing functional tests and you have people with development chops, it's a great choice. So a couple tools to make your life easier. Spoon is a tool also by Square. It lets you run your instrumentation tests on local Android devices that are plugged into a hub, and then it generates a nice looking report that's fairly simple. So if you're writing unit tests, if you're writing tests in JUnit and you want to run them on real devices, you have them in your cabinet right now, maybe you should pull them out, plug them into a hub, and you can run something like this. You can even hook it into a continuous integration environment and kick them off automatically. Spoon also lets you do things like take screenshots from within your unit tests so you can actually see the application in action on those local devices. Because they're on a hub, you're limited to how many local devices you can actually host, but it's free, and it's definitely worth it if you're running unit tests. You don't just have to run in the simulator emulator against one device at a time. You can run them in parallel. On the iOS side, similar but not entirely is the concept of bots. It's also new to Xcode 5. So bots allow, it's essentially an out-of-the-box continuous integration environment. Once you're set up, it's going to let you run your tests, and then it's going to also build you a nice-looking report. And if you set up the bot correctly, or specifically in a way that lets you test on real devices, then you can actually use your devices in the same way that you would use Spoon for on the Android side. Real quick about commercial frameworks. So in addition to all the tools I just went over, which are all open source, very popular, not just on the indies or hobbyist levels, but you'll see, especially with frameworks like KIF and Robotium, you'll see enterprises using them as well. That's not to say that there are not commercial tools available, and it's just important that when we look at commercial tools, we set some expectations. On the Plus, we're going to get really good support. We're likely to have an SLA with the company. We can probably be fairly certain that, unlike a brand new open source project, that this company is going to be around for a while. The tool will be around for a while, so our investment will be somewhat safe. And it's also going to ship with enterprise level integrations. So think integrations with our build systems, plugins for issue tracking, and so on. And some of the open source tools are maybe not so heavy on the integration side of things. Conversely, these tools are proprietary. They're likely to have actual proprietary languages involved, which is going to require some expensive on-site training to get ramped up. Finding people with the skills in these tools is often difficult to do. So it's just important that we know that going in, and evaluate them knowing that you're going to get locked in to the commercial offering. When choosing a tool, there are a few questions that we can ask to help us choose the best tool for the job. So it's very similar to when we're talking about what are we actually trying to automate. We can ask those same questions to help us narrow down a tool. So what exactly are we looking to achieve? What are we going to test? Are we testing the code? Are we testing functional flows? Are we testing some sort of full end-to-end integration? What exactly are we trying to accomplish? And what is the end goal? Are we looking to get more code coverage? Are we looking to free up our time to do exploratory testing, which is probably that would be the healthy approach, and then who's actually going to be writing these tests, right? So are these developers or people with developer skills? Are they going to then they can maybe choose a more powerful tool that lets them do a lot. On the other hand, it's if it's a QA team with maybe not the most Java or Objective-C experience, they're going to look at a tool, one of the Cucumber-based frameworks, and maybe have a lot of success there. It will enable them to do much more than they ever would if they were to have to go take classes in software programming and so on. And then before we jump into QA, I'll just talk a little bit about what I do here at AppThwack. So it's a cool position to be in because I don't have a vested interest in any particular tool out there for automating. I just care that people are actually taking a healthy approach to automated testing. Because if you're taking a healthy approach to automated testing, it means that you're actually going to run automation on a consistent basis and build quality applications. AppThwack lets you actually run your application on real devices. We have a few hundred here in the lab. It lets you get those results in minutes. It's essentially, we manage the lab for you. We maintain the devices. We have them hooked into an automation infrastructure. So essentially, you develop your tests locally, maybe run them on 1 or 2 devices, then upload them to our system, and it will run on hundreds of them. And then the output from running on AppThwack is a nice report that takes all of those hundreds of devices worth of data and crunches it down and shows you exactly where you should look. So again, it's in the cloud. It's going to give you high-level patterns. It's going to give you performance. Just by default, it's going to track a bunch of performance metrics. And then lastly, it's going to show you one-to-one pixel mappings for the screens on the various devices, so you can catch real-world layout issues complete with the Chrome on the top and bottom of the device. And with that, I will open it up to Q&A.
All right, thank you, Trent. It's very informative. Appreciate it.
Thanks.
Making sure you can hear me. Yeah, we have a couple questions from the group. The first one has to do with reporting recommendations, and specifically if you have any suggestions for best practices for reporting results to the various stakeholders, and anything about whether it really is okay to care about code coverage or not.
Sure. So first we'll address how to do the reporting for automated test results. So depending on the types of tools and the types of automation that you're running, the output could be vastly different. So if you're running just raw unit tests, you're likely going to get a pass-fail at the end of the day. I would say that if you're going to developers and you're going to go and take, here's our functional tests and here's a pass-fail, on the reporting side, simply wrapping that up in a high-level way that allows them to dig deeper if they want to into any specific issue, but lets them see like these are the most important issues. So, we know that on these specific tests that CPU usage is twice as much as it used to be. What changed, right? Those types of knowledgeable conversations, especially between QA and development, are going to be really important. I've seen a lot of talk about things like dashboards when it comes to introducing this to management, or if you're an agency and you're dealing with end customers who are actually going to consume the test results, for instance, then you're probably going to strip it all the way back, and then it's going to be things like, here's how many tests passed, here's how many tests failed, here is what our performance looks like over time. And then here are a bunch of screenshots, and this is how we've tested, right? So it's more of the how you're testing, not so much the what. Whereas when you're talking to developers, it's going to be a heavy emphasis on the what exactly are we testing, what kind of data did we actually gather, and how we can use it. The second part of the question, can you remind me again of the second part of the question?
No problem. And it has to do with okay to care about code coverage.
Oh, sure. I think caring about code coverage, it's definitely an important thing to think about. On the other hand, much like taking the approach that we're going to have 100% automation, the 100% code coverage thing can set your expectations maybe a little too high, right? If the goal at the end of the day is going to be 100% code coverage, you might actually cut some more helpful testing that you could be doing instead that maybe doesn't contribute to code coverage but would contribute to actually finding real issues that are going to affect our application stability, because we're all going towards 100% code coverage. That said, over time, I mean, if you look at your code coverage and you're below, say, 25% or below 50% or something like that, then it's probably something to look at. You could think of this as in the same way that we talked about when we talked about data-driving tests and knowing our matrix. The same could be said of our actual source code. So, if we have 60% coverage, what are we actually covering with the 60%? If we have 80% coverage, like what is the 20% that we're not covering? Is that 20%, the most heavily used portions of the application? Probably not, but if that's the case, then what does it matter that we have 80% coverage? That would be my feedback on that.
Great, thank you. And then this question really has to do with kind of estimating how much time you think it would take to actually do writing the automated testing. So you give me any heuristics on how much time you think is a good estimate on that should be planned in for writing test cases or automated test scripts for, like, say, an Android app? And the second part of that is really, how about when you're updating an existing application? Give me any heuristics around how do you do that, those estimate levels?
Sure. So I don't think that there's going to be some magical number, or maybe not even a formula here that's going to tell us that. It's totally going to come down to what kind of application are we dealing with, and how complex is it? Is it mostly self-contained? Is it talking to a server? Is it talking to external devices, right? Like, what exactly are we testing, and how complex is it? Because the more complex the application, the more time it's going to take us to actually write scripts. That said, there are certainly things that we can automate right off the bat that you're likely testing for all apps that are sort of universal. So think like basic compatibility testing. So installing the application across a wide swath of device configurations in various states. That type of thing is going to be true for all applications, and it's definitely something that can be automated very, very quickly. Whereas when we start talking about true functional flows, testing things through our application, those types of things are much more complex, especially if they involve systems and not just the single application. So I don't know if that actually answers the question in a very valuable way, but it's a difficult one. It's sort of asking how long do software projects in general take, and it totally depends on the software and what the scope is. The second part, for updating applications and estimating what amount of time should be spent on those updates to get our scripts. I think that this is going to be an increasingly large thing, because because it's a software project and you're maintaining a code base, you make changes to the code, you have an update to the code. It's entirely possible that not only now do you need to automate tests for the new functionality and the types of, and where that new functionality intersects with the existing functionality, you're also going to need to go back and make any changes to the existing code base. And I think that this is fairly obvious if you come at this from an automation standpoint or a software development standpoint. But when you're planning for automation as an organization, it's oftentimes left out of the estimates that we are going to be hauling along an increasingly large legacy code base on the automation side, just the same way that we do on the actual applications code base. So much like my answer to the first one, the amount of time you're going to spend there, it's going to be growing steadily over time, but it's certainly going to be related to how much and what was changed in the application will depend. If you change something drastically, maybe all of the automation pre-existing is wiped. I mean, that would be probably not very likely, but it's entirely possible. So.
Okay. Thanks. This one has to do again with kind of a best practice and really breaking down the barriers between or aligning closer with between development and testing. And the question is really, what are some best practices for working with developers to ensure application code is written to be more easily tested with automation?
No, that's an excellent question. So first and foremost, I would say it's very important, when we talk about no barriers between dev and QA, that when tools are being adopted, when testing strategies are being adopted, that development and QA are in the same room making those decisions together. And there should be equal buy-in from both, because it's going to be impossible for a QA team to write effective automation if the developers are not putting the correct hooks into their code to make testing actually possible. And it's definitely a shift in thinking if you're used to just writing code and shipping it out the door, to suddenly think about, okay, well, not only do I need to think about how am I writing my piece of software and making this function the way that I want it to, but how are we actually going to test this later? How are we going to simulate it, emulate it, and so on? One way to do this is that you start pushing a test-driven development type scenario where people are writing tests for their code, through doing that, they're intrinsically putting hooks into place that QA can then use later on to drive the application. But that would be the the biggest thing is just making sure everybody buys into the tools and the strategy up front, and that everybody knows the importance and agrees upon what exactly the goal here is, right? The goal is to make testing easier, more consistent, to make it so that when QA finds issues and reports it to developers, that the developers trust that there is in fact an issue. And not only that, they might even be able to run the tests that the QA team is running as well, so they can actually reproduce locally. All of those, kind of come to this vision that QA and development are really not two separate teams. They're one. They're the closer they can be to one organization, the better.
Great. Sounds like Agile, near and dear to my heart. We were talking earlier a little bit about some of the commercial tools. Can you give a few examples of some of the commercial tools that are out there? Maybe not that you recommend, but maybe that are just out there for people to consider.
Sure, yeah. So I'm not super familiar with very many of them. You can look. There's SOSTA is one popular enterprise type testing solution. They have a recorder in their own language for writing tests, and you can run those on the emulators or on real devices you have locally. Another one. Yamo has a solution that's JAMO. There's a whole host of them, and then if you go into the more traditional enterprise test players, so if you look at, for instance, Rational and Rational Robot, or you go to Mercury and you start looking there, you'll also find some support for automated testing. One big shift, I would say, and I tried to spell it out on the when I discussed the open source tools versus the commercial tools, is that today you see definitely more and more adoption of either the test frameworks that are being distributed with the various frameworks by Apple or Google, or by very popular open source projects around those. So think things like KIF and Robotium. You definitely see a lot more of that now than organizations saying, okay, well, we're going to buy this really expensive tool, we're going to pay a really big support fee, and so on. Especially now with mobile testing, where not only do you need to buy the tool, you also will need to buy a bunch of devices, you'll need to pay people to maintain those devices, and so on. So the costs are much higher than they used to be.
Okay, we probably have time for about 2 more questions. This one's an iOS question for an iOS developer or tester. Is UI automation harder to maintain than KIF, or roughly the same except for the JavaScript versus the Objective-C behavior?
Sure. So I don't know if you disregard the fact that it's JavaScript versus Objective-C, again, because Objective-C is the same code base that we're writing the actual application in, then it just makes sense to stay in that language. It gives us a lot of freedom. We're not talking through another layer of abstraction from a language standpoint. When it comes to the types of tests we can write, we can write fairly similar tests, again, because we're using the JavaScript. There are some limitations to what exactly we can test. So the types of testing are going to be different. From a maintainability standpoint, I don't know if there's really going to be that big of a difference, besides the fact that it's going to be much easier to stick with one environment versus the other. So if I had a team of programming savvy QA people, I think I would go with something like KIF versus UI automation.
Okay. So this is a 3-part question, and it kind of speaks to some of the folks that maybe aren't developers and on the Android platform specifically. What are your views on MonkeyTalk as a platform for testing Android 2 or Android?
Okay, so this is the first part of the question, I'm assuming?
Yeah, first part of the multi-part question.
Okay, sure. So MonkeyTalk is another automation framework that I didn't actually mention in the slides. It's also open source. I didn't mention it because we don't see its adoption rate is maybe not as high as the other ones that we discussed. It's certainly an interesting tool, especially for the fact that it comes with a recorder. So it may appeal to certain types of teams. On the downside of this framework, it does use a proprietary language. So again, there's going to be the learning piece that goes along with this, so you're going to have to learn a proprietary language, whereas all of those other open source automation frameworks are using widely known languages. So you're writing in, whether it's JavaScript or Java or Objective-C, it's using one of the standard languages. Or even in the case of Cucumber for BDD, that human readable language is spec'd out and is fairly popular. Whereas with Monkey Talk is very specific just to Monkey Talk, which is why I don't really mention it. So yeah, and I think from a cross-platform testing perspective, that's, again, that selling point. You could use it for the Cucumber-based testing. You could use it for Appium, for instance. I don't think that is a healthy, that shouldn't be your primary reason for choosing a tool, is that where you need to test both Android and iOS. And because if you think that you're going to write one test that runs on both, I think that you're going to be mistaken unless somehow your applications are so nearly identical and fairly simple that you can actually write one-to-one code. At some point, you're going to have to branch out, though, and I don't think that's probably the most realistic goal. I think you should choose a tool based on, how will it let you do the kinds of tests you want to do, and will it let you do them quickly. And typically with those cross-platform tools, if you actually try to write yourself one test that runs on both, you're going to have to make some compromises somewhere. So your test might not be as powerful or thorough just so that they can run on two platforms.
Okay, and then just the last part of this question, I'm going to sneak it in real quick here. Which tool do you think is best for a non-developer QA person to get started with Android automated testing?
Sure. So for a non-developer to get started, it's hard to argue with the Cucumber-driven test framework. So something like Calabash, just because it's so easy to get up and running, especially from a non-developer standpoint. That said, you'll quickly start bumping into some of the limitations, and you'll find yourself dropping into the code. So, there are pros and cons to both. For non-developers tasked with writing tests, it also might actually be worth it to look into some of the commercial offerings, especially those with recorders. Ideally, if you're a non-developer and you're tasked with testing, you have a developer resource somewhere that is tasked with helping you with writing the parts of the tests that the framework isn't so good with. So for instance, if you're using Cucumber and you're using Calabash, having a developer with some Ruby chops at your disposal so that when you need something a little more complex, you can have them build you the building blocks and then you can consume them. That would be a healthy approach. But yeah, I don't know if there's really any off-the-shelf thing that's going to get you up and running with very little overhead. There's no like magic bullet here.
Okay. All right. Well, thank you. That was our last question, and thank you, Trent, for presenting today. Thank you all for attending the presentation. Again, this will be available on the Technology Association of Oregon's website, techoregon.org. You'll also see a recording of the session in case anybody wants to go back and revisit or turn a colleague onto it so they can listen to it again. So again, thank you, Trent, and thank you again to our sponsors, Jenkins Business Applications, Rally Software, and Salesforce.com. And everyone, I hope you have a pleasant day, and thank you again for joining.
Yeah, and I'll just add in there that if you submitted a question and it didn't get answered, we'll answer it and submit it with the recording as a Q&A cheat sheet. So don't worry if you didn't get your question answered. We'll get it answered and get it back to you.
Thanks a lot, everyone.
Thank you.
Thank you.